Hello, this is the submission of our Sapelfeld and Robert Schmidt for the OpenAirInterface RAN Timing Advanced Challenge. Our code is based on the OpenAirInterface tag version 2022 second week. We concentrate purely on the uplink direction for modifying the distance. In the downlink, it is as if the UE stayed at distance 0. We begin as in Lab 01 by starting a core network, the GNODP, and the UE. GNODP and UE both have channel modeling and telnet server enabled, and the connection is established, which we can see by the UE IP address being assigned. Next, we start by moving the UE away in steps of 200 samples, corresponding to 1000 meter steps. We see that at about 1000 samples or 5000 meter, the connection breaks since the sample received at the GNODP are cut off as described in the report. Next, we apply our patches that modify the telnet server, RF simulator, and UE code. Through the telnet server help command, we see that a number of the commands to set and get the virtual distance of a UE and the correct RF simulator timestamps can be modified. The distance set function is important to correctly update the internal circular buffer. The current RF simulator timestamps retrieval function is useful for measuring the virtual time. Again, we move the UE away in steps of 1000 meter or 200 samples. We see that the connection does not break. Furthermore, the script verifies that the UE uses the right timing advance. We calculated the expected absolute TA from the distance and compare it with what the UE had been updated from the base station. The script also shows that the actual sample offset and what the UE uses internally, which is always very close. We have verified that through our modification, it is possible to go up to at least 100 km. Finally, we wrote a script to emulate the moving UE in smaller intervals and to compute the corresponding virtual speed of the UE. We perform uplink traffic to stress the connection. The UE moves 15 meters away every 100 millisecond while time up to 3 km. We see that the connection is not lost even though the UE has virtual speed of around 5000 km per hour. Note that the limits of the speed depends on how often the GNODP sends timing advance commands, which is every 10 frames in OAI currently. With this frequency, it is possible to go even higher and indicates that timing advance commands are sent too often in OAI. Also, in a real system, UEs experience signal challenges due to the Doppler shifts, which is a major limiting factor as indicated by the maximum speeds possible when performing frequent timing advance of this. During the work, we found a number of bugs which are also described in the report. In particular, the downlink timing advance made by the UE are lower and steps of 2000 meters are not feasible. Also, the initial timing commands estimation at PRISE seems to be hard-coded to sampling frequency of 30 mega samples per second, which leads to wrong timing advance estimation when another sampling frequency is used as in the initial lab instructions.